Hello there and welcome to the Dreamy Science Channel. Let's start right away with the most amazing mysteries in our universe. There are clouds in space that smell like raspberries and taste like rum. Deep in the vast emptiness between stars, floating in regions so remote that sunlight has never touched them, drift enormous clouds of gas and dust. These molecular clouds are the birthplaces of stars, but they hold a delightful secret. When scientists analyze their chemical composition, they discover molecules that would be familiar to any baker or bartender. Ethyl formate, the compound that gives raspberries their distinctive flavor and rum its characteristic aroma, exists in abundance throughout these cosmic clouds. Of course, space has no air to carry scent, and these clouds are far too cold and thin for any human to survive in them. But the chemistry is there, drifting silently through the galaxy. It's a gentle reminder that the universe is not so alien after all. The same molecules that bring pleasure to our senses here on Earth are scattered throughout the cosmos, waiting patiently in the dark between stars. Some planets rain diamonds, while others have glass snow that falls sideways. In the outer reaches of our solar system and beyond, weather takes on forms that would seem magical to us. On Neptune, the crushing pressure and extreme temperatures may create diamonds in the atmosphere. These precious gems, formed from compressed carbon, would fall like glittering rain toward the planet's core, accumulating in vast layers of crystalline treasure that no one will ever see. Meanwhile, on a planet called HD 189733b, located 63 light-years from Earth, the weather is even more extraordinary. This distant world experiences glass rain. Silicate particles form in the upper atmosphere and fall like snow, but not straight down. The planet's winds reach speeds of over 4,000 miles per hour, causing the glass to fall sideways in sheets of sparkling, deadly beauty. These storms of crystal and diamond happen in silence, in places where no human eyes will ever witness their strange elegance. There are auroras on other planets that would make Earth's northern lights look pale. The dancing lights we see in our polar skies, those green and blue curtains that shimmer and wave, are just a gentle preview of the light shows happening elsewhere in our solar system. On Jupiter, auroras burn with an intensity hundreds of times brighter than anything we see on Earth. They pulse in ultraviolet and X-ray wavelengths, creating patterns of light that stretch across areas larger than our entire planet. Saturn's auroras are powered by the same solar winds that create our own, but they interact with the planet's magnificent ring system to create something entirely unique. The charged particles dance not just in the upper atmosphere, but also around the rings themselves, creating spirals and waves of light that flow like luminous rivers through space. These cosmic light shows happen continuously, painting the darkness with colors we can barely imagine, all in the perfect silence of the vacuum. The universe hums with a frequency we can barely detect. If space had air to carry sound, the universe would not be silent at all. It would be filled with a deep, constant hum. This cosmic background hum comes from the leftover energy of the Big Bang itself, stretched and cooled by billions of years of expansion. We can detect this ancient song with sensitive instruments, but it's far too low for human ears to hear. The frequency is incredibly stable, like a cosmic tuning fork that has been ringing for over 13 billion years. Some scientists describe it as the universe's heartbeat, a steady rhythm that underlies everything we see and know. Even now, as you rest, this primordial melody flows through the space around you, a lullaby from the beginning of time itself. There are magnetic fields in space that could lift mountains but feel gentle as silk. Throughout the galaxy, invisible magnetic fields weave through space like cosmic spider webs. These fields are incredibly powerful by our standards. Some could lift entire mountains if they existed on Earth. Yet they exert their influence so gently that spacecraft pass through them without the slightest turbulence. These magnetic fields guide cosmic rays on curved paths that span thousands of light years. They shape the spiral arms of galaxies and help funnel matter into the formation of new stars. Like invisible hands, they reach across vast distances to touch and guide the dance of cosmic matter. They are the universe's way of staying organized, keeping things flowing in graceful patterns rather than chaotic randomness. Some moons in our solar system have hidden oceans warmed by the tides of giant planets. Beneath the frozen surfaces of several moons in our outer solar system lie vast oceans of liquid water. Europa, one of Jupiter's moons, hides an ocean beneath its ice that may contain more water than all of Earth's seas combined. This hidden ocean stays liquid not because of heat from a sun, but because of something far more gentle, the gravitational massage of Jupiter itself. As Europa orbits its giant parent planet, Jupiter's gravity flexes the moon's interior, generating heat through friction. This tidal heating keeps the hidden ocean warm and liquid, creating a potential oasis for life in the cold outer reaches of our solar system. Similar oceans may exist on other moons, each one a secret sanctuary of liquid water, quietly maintained by the gentle pull of gravity across millions of miles. The space between galaxies is filled with threads of dark matter we cannot see, but that connect everything. When we look at the night sky, the darkness between stars seems empty, but it's not. Invisible threads of dark matter stretch through this apparent emptiness, connecting galaxies across billions of light years. These filaments form a vast cosmic web, a hidden architecture that gives structure to the entire universe. Dark matter doesn't shine or reflect light, so we can only detect it through its gravitational effects. But those effects reveal a universe that is far more connected than it appears. Galaxies aren't isolated islands floating in empty space. They are beads strung along invisible threads, part of a grand tapestry that spans the observable universe. This cosmic web is constantly evolving, slowly shifting and flowing like a living thing, all without making the slightest sound. There are storms on the sun that could swallow 100 Earths, but feel no fiercer than a gentle breeze. The surface of our sun is constantly churning with magnetic storms that dwarf anything we experience on Earth. Solar flares and coronal mass ejections release more energy than 1 billion atomic bombs, hurling charged particles across the solar system at incredible speeds. Yet for all their power, these storms have a strange gentleness to them. Unlike hurricanes or tornadoes, solar storms have no sharp edges, no violent winds. They flow like luminous rivers of plasma, following graceful curves dictated by magnetic field lines. When these storms reach Earth, they don't batter our atmosphere with destructive force. Instead, They paint our skies with auroras, transforming their immense energy into something beautiful and peaceful. The sun's fury becomes Earth's light show, violence transformed into wonder. Some asteroids tumble through space in perfect mathematical harmony. Among the countless rocks that orbit our sun, some move with an almost musical precision. These asteroids don't just spin randomly as they travel through space. They tumble in complex rotations that follow mathematical patterns, like cosmic ballet dancers performing intricate choreography in the darkness. One asteroid might complete exactly 3 rotations around one axis for every 2 rotations around another, creating a motion that repeats with clockwork precision. Others tumble in patterns so complex that it takes supercomputers to predict their exact orientation at any given moment. Yet for all their complexity, these motions have an underlying harmony, a mathematical beauty that emerges from the simple laws of physics acting over millions of years. The cosmic microwave background radiation tells us bedtime stories from the universe's childhood. Filling every corner of space is a faint glow, the stretched and cooled remnant of the light that first shone when the universe became transparent. This cosmic microwave background is like a photograph of the universe when it was only 380,000 years old, a baby picture taken when the first atoms were forming and light could finally travel freely through space. This ancient light carries within it tiny variations, subtle differences in temperature that tell the story of how the first structures began to form. Like reading the grain in an old piece of wood, scientists can decode these patterns to understand how galaxies and stars and planets eventually came to be. It's a gentle reminder that we are all part of an ancient story, one that began with the faintest whisper of light in the cosmic dawn. There are planets where the rain never reaches the ground. On some distant worlds, the atmosphere is so hot and dry that raindrops evaporate completely before they can fall to the surface. These planets experience phantom precipitation, clouds that form and release moisture that simply vanishes into the air below. From space, these worlds would appear to have weather, but a visitor standing on the surface would never feel a drop of rain. This ethereal precipitation creates a strange kind of weather cycle, where water rises and falls but never completes its journey. The rain exists only in the upper atmosphere, a ghostly reminder of the water cycle we know on Earth. It's weather that happens in theory, but not in practice. Precipitation that lives only in the space between the clouds and the ground. Some comets carry the building blocks of life on journeys that span millions of years. Comets are often called dirty snowballs, but they're really more like cosmic time capsules. These ancient wanderers carry within their icy cores the organic compounds that were present when our solar system was young. As they travel their long elliptical orbits, taking decades or centuries to complete a single journey around the sun, they preserve these delicate molecules in the deep freeze of space. When a comet approaches the sun, it begins to sublimate, releasing its cargo of water vapor and organic compounds into space. Some of these molecules may eventually find their way to planets, seeding new worlds with the chemical ingredients needed for life. In this way, comets serve as gentle gardeners of the cosmos, planting the seeds of possibility wherever their wandering paths may lead them. The tails of comets always point away from the sun, creating cosmic weather vanes that show the direction of stellar wind. Perhaps the most elegant feature of comets is their tails, those gossamer streams that stretch for millions of miles through space. These tails don't trail behind the comet like the wake of a boat. Instead, they always point away from the sun, regardless of which direction the comet is traveling. This happens because comet tails are not created by the comet's motion through space, but by the pressure of sunlight and the solar wind pushing the comet's sublimated material away from our star. As a result, when a comet is traveling away from the sun, its tail actually leads the way, streaming out in front like a luminous banner announcing its presence to the cosmos. There are galaxies that rotate so slowly they barely seem to move at all. In the vast collection of spinning stellar cities that populate our universe, some galaxies turn with such leisurely grace that a single rotation takes over 1 billion years to complete. These ancient spiral systems drift through space like cosmic pinwheels moving in slow motion, their arms unwinding and rewinding in patterns so gradual that entire civilizations could rise and fall between one turn and the next. The stars within these galaxies follow orbital paths so vast and unhurried that they seem almost stationary against the backdrop of space. A star near the outer edge might travel for hundreds of millions of years just to complete a fraction of its journey around the galactic center. It's a reminder that the universe operates on timescales that dwarf human experience, where patience is measured not in moments or years, but in eons. Some nebulae glow with colors that exist nowhere else in nature. Scattered throughout our galaxy are clouds of gas and dust that shine with hues so specific and pure that they cannot be found anywhere on Earth. These emission nebulae are illuminated by nearby stars, their gases excited to luminescence in narrow wavelengths that create colors of extraordinary intensity and purity. The Orion Nebula glows with a particular shade of red that comes from hydrogen atoms releasing photons at exactly 656.3 nanometers. Other nebulae shine in precise greens and blues, each color corresponding to specific elements being energized by starlight. These cosmic stained glass windows paint the darkness with pigments that exist only in the rarefied conditions of interstellar space, creating artworks that span dozens of light years and glow for millions of years. There are binary stars that dance around each other for billions of years without ever touching. Throughout the galaxy, stellar pairs perform gravitational waltzes that stretch across cosmic time. These binary systems consist of two stars locked in orbital embrace, circling each other with mathematical precision while maintaining distances that ensure they will never collide. Some of these stellar dancers are so close they complete their cosmic ballet in a matter of hours, whipping around each other at incredible speeds while remaining forever apart. Others are separated by distances greater than the orbit of Pluto, taking centuries to complete a single graceful turn around their common center of mass. Yet regardless of their separation, they remain gravitationally bound, partners in a dance that began when the galaxy was young and may continue long after our sun has faded to darkness. The universe contains rivers of dark matter that flow between galaxy clusters. Invisible to our eyes but detectable through their gravitational effects, Streams of dark matter flow through space like cosmic rivers connecting distant galaxy clusters. These currents of unseen matter follow paths carved by gravity over billions of years, creating a hidden network of flowing mass that helps shape the large-scale structure of the universe. Like water flowing downhill, dark matter follows the easiest paths through the gravitational landscape of space, pooling in some regions and streaming through others. Galaxy clusters act like islands in these dark rivers, collecting matter as it flows past and using it to fuel their continued growth. The motion is so gradual and gentle that it can only be detected by observing how it affects the distribution of visible matter over vast distances and enormous spans of time. Some planets have such thin atmospheres that you could see stars during the day. On worlds where the atmosphere is gossamer thin, the sky during daylight hours would reveal a sight impossible on Earth. Stars shining clearly against a dark backdrop, even with the local sun blazing overhead. Without a thick blanket of air to scatter sunlight and create the blue dome we know so well, these planets experience a different kind of day. The transition from day to night on such worlds would be subtle and gradual, marked not by the disappearance of stars, but by the dimming of the landscape as the sun moves across the sky. Shadows would be sharp and well-defined, with no atmospheric haze to soften their edges. It would be a world where the cosmos remains visible at all hours, a constant reminder of the vast universe that surrounds every world. There are moons in our solar system that are perfectly smooth, covered in ice as flat as a skating rink. Among Jupiter's many moons, Europa presents one of the most serene surfaces in the solar system. Its icy shell has been smoothed by geological processes into plains so flat and featureless that they resemble a cosmic ice rink stretching to the horizon. The few cracks and ridges that mark its surface only serve to emphasize the remarkable smoothness of the terrain between them. This pristine landscape is maintained by the same tidal forces that keep Europa's hidden ocean liquid. The constant flexing of the moon's interior causes the ice shell to crack and refreeze, erasing impact craters and other surface features over geological time. The result is a world that appears freshly polished, as if some cosmic custodian has carefully maintained its gleaming surface for millions of years. Some stars pulse with rhythms so regular they could be used as cosmic metronomes. Scattered throughout the galaxy are stars that vary in brightness with such precise timing that they serve as natural timepieces. These variable stars expand and contract in regular cycles, their surfaces cooling and heating in patterns that repeat with clockwork accuracy over periods ranging from hours to months. The most reliable of these stellar clocks are so consistent that astronomers use them to measure distances across the universe. Like lighthouse beacons flashing in the cosmic night, they provide reference points that help map the three-dimensional structure of space. Their steady pulses have been beating out cosmic time since before our solar system formed, and they will continue their rhythmic variations long after our sun has exhausted its fuel. The space between planets is filled with a gentle breeze of particles from our sun. What we think of as empty space within our solar system is actually filled with a continuous, gentle flow of charged particles streaming outward from the sun. This solar wind is incredibly thin by earthly standards, far more tenuous than the best vacuum we can create in our laboratories. Yet it fills the entire solar system with its subtle presence. This cosmic breeze travels at speeds of hundreds of kilometers per second, yet it exerts such gentle pressure that it can only be detected with sensitive instruments. When it encounters the magnetic fields of planets, it creates beautiful auroras. When it pushes against comet tails, it sculpts them into graceful streamers. The solar wind is the sun's way of touching every corner of its domain, a constant gentle reminder of the star that governs our cosmic neighborhood. There are asteroids that have their own tiny moons, creating miniature solar systems in space. Even among the smaller bodies of our solar system, the dance of orbital mechanics creates delicate relationships. Some asteroids, themselves only a few kilometers across, are accompanied by even smaller companions that orbit them like tiny moons. These asteroid systems represent gravity's ability to create order and structure at every scale. The largest of these asteroid moons might be only a few hundred meters in diameter, taking days or weeks to complete their orbits around their parent bodies. The gravitational forces involved are incredibly weak by planetary standards, yet they are sufficient to maintain these relationships across millions of years. It's a reminder that even the smallest objects in space can participate in the cosmic dance of orbital mechanics. Some regions of space are so empty, they contain only a few atoms per cubic meter. Between the galaxy clusters, in the vast voids that separate one cosmic city from another, space reaches a level of emptiness that is difficult to comprehend. These cosmic voids contain so little matter that a volume the size of Earth might hold fewer particles than a child's balloon. Yet even in these seemingly empty regions, there is structure and beauty. The few atoms that do exist are organized by magnetic fields and gentle gravitational influences, creating patterns and flows that span millions of light years. These cosmic deserts are not lifeless wastelands, but rather the quiet spaces between the universe's more crowded neighborhoods, places where emptiness itself becomes a kind of presence. The magnetic field of our galaxy extends far beyond its visible edges, creating an invisible bubble around all the stars we can see. Like a soap bubble blown from cosmic proportions, our Milky Way galaxy is surrounded by a magnetic field that extends well beyond the spiral arms and stellar halo that define its visible boundaries. This galactic magnetic field is shaped by the rotation of the galaxy itself and by the movements of charged particles throughout the interstellar medium. This invisible boundary helps protect the galaxy from some of the high-energy cosmic rays that stream through intergalactic space, deflecting them around the galaxy's edges like water flowing around a stone. The field is constantly shifting and evolving, responding to stellar winds, supernova explosions, and the complex currents of plasma that flow through interstellar space. It's the galaxy's way of maintaining its integrity as it travels through the cosmos. There are planets where diamonds fall as snow and pool in vast crystalline lakes. In the crushing depths of some gas giant atmospheres, the extreme pressure and temperature conditions can transform ordinary carbon into diamonds. On Neptune and Uranus, scientists believe that diamond precipitation may be a regular occurrence. with crystalline carbon forming in the upper atmosphere and falling toward the planetary cores like glittering snow. Over geological time, these diamond snowfalls could accumulate into vast deposits, creating oceans of liquid diamond surrounding the rocky cores of these distant worlds. The diamonds would exist under such extreme conditions that they might behave more like liquid than solid, flowing and pooling like luminous lakes of crystallized carbon. It's a treasure beyond imagination, hidden in the depths of worlds so distant and hostile that no human eyes will ever witness their sparkling beauty. There are regions in space where time flows differently, creating pockets where moments stretch like honey. In the vast emptiness between stars, gravity's influence becomes so subtle that time itself begins to behave in curious ways. Near massive objects like black holes or neutron stars, time slows dramatically, but in the opposite extreme, in regions where gravity is nearly absent, time flows with an almost ethereal freedom. These temporal oases exist in the deep voids between galaxy clusters, where the pull of matter is so weak that a clock would tick ever so slightly faster than it would on Earth. The difference is impossibly small, measurable only by the most sensitive instruments. Yet it represents something profound about the nature of reality itself. In these quiet corners of the universe, time moves with a gentleness that mirrors the emptiness around it. Some cosmic clouds are so cold they could freeze air itself into snow. In the darkest reaches of space, molecular clouds exist at temperatures that approach absolute zero, the theoretical point where all atomic motion ceases. These frigid regions are so cold that if Earth's atmosphere were somehow transported there, the nitrogen and oxygen we breathe would instantly crystallize into delicate flakes of frozen gas. At these extreme temperatures, atoms move with such sluggish grace that chemical reactions slow to a virtual standstill. Molecules that would normally be highly reactive become docile and stable, allowing complex organic compounds to survive for millions of years in pristine condition. These cosmic deep freezers preserve the chemical heritage of the universe, maintaining libraries of molecular information in conditions of perfect, crystalline stillness. There are gravitational waves so gentle they stretch space by less than the width of a single proton. Rippling through the fabric of spacetime itself are waves so subtle that they can barely be detected even with our most sophisticated instruments. These gravitational waves are created when massive objects accelerate through space, sending tiny distortions through the very geometry of the universe. When these waves pass through Earth, they stretch and compress space by amounts so minuscule that they make a proton look enormous by comparison. Yet despite their gentleness, they carry information across billions of light years, telling stories of colliding stars and spinning black holes in distant galaxies. They are the universe's whispers, so soft that it took humanity decades to develop ears sensitive enough to hear them. Some galaxies are surrounded by halos of ancient starlight that glow like cosmic fireflies. Surrounding many galaxies are vast spherical regions filled with stars so old they remember the universe's youth. These stellar halos contain stars that formed before their host galaxies fully assembled, creating ghostly shells of ancient light that extend far beyond the bright spiral arms or elliptical cores we typically associate with galactic structure. The stars in these halos move on long, leisurely orbits that take hundreds of millions of years to complete. They drift like luminous wanderers through the outer reaches of their galaxies, following paths so elongated that they spend most of their time in the quiet darkness between the more densely populated regions. Their faint glow creates a subtle aurora around their galaxies, visible only to the most sensitive telescopes. There are cosmic phenomena that repeat with such precision they could regulate celestial clockwork. Throughout the universe, certain events occur with timing so exact that they serve as natural chronometers on cosmic scales. Pulsars spin with such regularity that their lighthouse-like beams can be used to detect the most minute changes in spacetime. Some binary star systems eclipse each other with such predictable timing that their brightness variations have been used to test the fundamental constants of physics. These cosmic timepieces maintain their precision across millions or even billions of years, their rhythms governed by the most basic laws of physics. They pulse and flash and vary with a steadiness that makes human timekeeping seem crude by comparison. In their regular beats, we can hear the universe keeping time with itself, counting out the eons with mechanical precision. Some planets orbit their stars in perfect mathematical harmony, like notes in a cosmic symphony. In certain solar systems, planets have arranged themselves in orbital relationships so precise they seem almost too elegant to be natural. These resonant systems feature planets whose orbital periods are related by simple mathematical ratios, creating gravitational harmonies that have remained stable for billions of years. In some cases, one planet completes exactly 2 orbits for every 3 orbits of its neighbor, or 3 orbits for every 4 of another. These relationships create a kind of celestial music, with each planet contributing its own note to a gravitational symphony that plays out over cosmic time scales. The planets tug on each other with perfectly timed gravitational pulses, maintaining their musical relationships through the endless dance of orbital mechanics. There are stellar nurseries where baby stars form in clusters like cosmic gardens. Deep within the galaxy's spiral arms lie vast molecular clouds, where stars are born not as isolated individuals, but as members of stellar families. These star-forming regions create clusters of newborn suns that emerge together from their gaseous cocoons, siblings in light that will share their cosmic neighborhood for millions of years. The process happens with surprising gentleness as gravity slowly gathers the diffuse gas into denser and denser knots until nuclear fusion finally ignites. The birth of each new star illuminates the surrounding cloud, creating glowing caverns of colored light that stretch for light years in every direction. These stellar nurseries are among the most beautiful regions in the galaxy, painted in hues that exist nowhere else in nature. Some moons experience tides so extreme they stretch and compress like cosmic stress balls. Throughout our solar system, moons orbiting close to massive planets experience gravitational forces that knead their interiors like invisible hands. These tidal forces are strong enough to generate heat through friction, keeping hidden oceans liquid beneath frozen surfaces and powering volcanic activity on worlds that should be cold and dead. The most extreme examples of this tidal heating create moons that are constantly reshaping themselves, their surfaces cracking and reforming in response to the rhythmic squeeze of their parent planet's gravity. It's a gentle form of cosmic massage that has been continuing for billions of years, maintaining warmth and activity in places that would otherwise be frozen wastelands. There are cosmic structures so large, they challenge our understanding of how the universe organizes itself. Stretching across hundreds of millions of light years are filaments of galaxies that form the largest known structures in the cosmos. These cosmic threads connect distant galaxy clusters like beads on an invisible string, creating a web-like pattern that spans the observable universe. The scale of these structures is so vast that light itself takes hundreds of millions of years to travel from one end to the other. Yet despite their enormous size, they maintain their integrity through the gentle influence of dark matter, which provides the gravitational scaffolding around which ordinary matter can organize itself. They represent the universe's ability to create order and structure on the grandest possible scales. Some cosmic events happen so slowly, they span entire geological epochs. While we often think of space as a realm of violent explosions and dramatic collisions, many of the most significant cosmic processes unfold with geological patience. Galaxies merge over hundreds of millions of years, their spiral arms slowly intertwining like cosmic dancers moving to music too slow for human perception. Stars evolve through distinct phases over billions of years, gradually changing color and brightness as they age. Even the expansion of the universe itself happens so slowly that it can only be detected by observing the most distant objects. These slow cosmic processes remind us that the universe operates on time scales that dwarf human experience, where change is measured not in moments, but in eons. There are regions of space where magnetic fields create invisible sculptures spanning thousands of light years. Throughout the galaxy, magnetic fields carve out vast three-dimensional structures that exist only in the realm of charged particles and plasma. These invisible sculptures follow the contours of gravitational wells and stellar winds, creating complex geometries that can only be detected through their effects on cosmic rays and radio waves. Some of these magnetic structures channel the flow of interstellar gas, helping to trigger star formation in specific regions while preventing it in others. They act like cosmic plumbing, directing the flow of matter through the galaxy according to patterns that have been evolving for billions of years. Though invisible to the eye, these magnetic architectures play a crucial role in shaping the visible universe we observe. Some asteroids tumble through space trailing clouds of their own dust, like cosmic comets. As these rocky wanderers journey through the solar system, the constant bombardment of micrometeorites slowly erodes their surfaces, creating tenuous clouds of dust particles that follow them along their orbital paths. These dust trails can persist for thousands of years, creating ghostly highways through space that mark the passage of asteroids long after they have moved on. The particles in these trails are so small and widely dispersed that they pose no danger to spacecraft. Yet they create a subtle presence that can be detected by sensitive instruments. When Earth passes through one of these ancient dust streams, the particles enter our atmosphere and burn up as meteors, creating gentle showers of shooting stars that connect us to the slow erosion of distant worlds. There are cosmic voids so empty they contain less matter than the space inside an atom. Between the great walls and filaments of galaxies lie regions of space so devoid of matter that they represent the closest thing to true emptiness that exists in nature. These cosmic voids are not completely empty, but they contain so little matter that their density approaches the quantum vacuum itself. Within these vast empty regions, which can span hundreds of millions of light years, the few galaxies that do exist drift in profound isolation, separated from their nearest neighbors by distances that boggle the imagination. The emptiness is so complete that a traveler crossing such a void would see only darkness in every direction for millions of years, with only the faintest glimmer of distant galaxy clusters marking the edges of their cosmic desert. Some planets have weather systems that have been raging for longer than Earth has existed. In the atmospheres of gas giant planets, storms can achieve a stability that allows them to persist for centuries or even millennia. Jupiter's Great Red Spot, a hurricane-like storm larger than Earth itself, has been observed continuously for over 300 years and may have been raging for much longer. These planetary storms maintain their structure through a delicate balance of atmospheric dynamics, powered by heat rising from the planet's interior and shaped by the rapid rotation of the world beneath them. They represent weather systems on a scale and duration that dwarf anything possible on Earth. Vast atmospheric rivers that flow in patterns too large and too long-lasting for any terrestrial comparison. There are binary systems where one star gently feeds material to its companion across millions of miles of space. In some stellar partnerships, one star has evolved to the point where its outer atmosphere has expanded beyond its gravitational grip, allowing material to flow across the space between the two stars, like a luminous river. This mass transfer happens so gradually and gently that it can continue for millions of years without disrupting either star's basic structure. The material streams between the stars following graceful spiral paths, dictated by the rotation of the system and the gravitational influence of both components. Where the stream impacts the receiving star, it creates a bright hot spot that glows with the energy of infalling matter. These systems represent stellar symbiosis on a cosmic scale, with one star extending its life by sharing its substance with its companion. Some cosmic rays have been traveling through space since before our solar system formed. Among the high-energy particles that constantly rain down on Earth from space are some that have been journeying through the galaxy for longer than our sun has existed. These ancient messengers carry information about cosmic events that happened billions of years ago, encoded in their energy and composition. During their epic journeys, these particles have been deflected by magnetic fields, accelerated by shock waves, and scattered by encounters with interstellar matter. Yet they have maintained their basic identity across cosmic time. When they finally encounter Earth's atmosphere, they create cascades of secondary particles that can be detected by instruments on the ground, allowing us to decode messages that have been traveling toward us since the galaxy's youth. Some galaxies drift through space in perfect silence, their billions of stars moving together like a cosmic migration. In the vast spaces between galaxy clusters, entire stellar cities travel through the darkness at speeds that would seem impossible if we could perceive them. These wandering galaxies carry their complete populations of stars, planets, and solar systems on journeys that span hundreds of millions of years. Yet from any perspective within the galaxy, the motion is imperceptible. The stars within these traveling galaxies maintain their relative positions with such precision that constellations remain unchanged throughout these epic voyages. A civilization on a planet within such a galaxy might observe the same star patterns for millions of generations, never knowing that their entire cosmic neighborhood is sailing through space towards some distant gravitational destination. These galactic nomads represent motion on the grandest possible scale, yet experienced as perfect stillness. There are stellar winds so gentle they take thousands of years to travel from one star to its neighbor. The space between stars is filled with an incredibly tenuous breeze of particles expelled from stellar surfaces. These stellar winds are far more delicate than even the softest earthly breeze, consisting of charged particles so widely spaced that they rarely interact with one another during their journey through interstellar space. As these gentle currents flow outward from their parent stars, they carry magnetic fields and trace amounts of heavier elements created in stellar cores. When the winds from different stars meet in the darkness between them, they create invisible boundaries and shock fronts that help shape the local interstellar environment. The interaction happens with such subtlety that it can only be detected through careful observation of how the particles affect radio waves and cosmic ray propagation. Some planets have gravity so light that their atmospheres extend into space like cosmic halos. On worlds where gravity's grip is particularly weak, the boundary between atmosphere and space becomes beautifully blurred. The gas molecules that make up these extended atmospheres move so slowly that they can escape the planet's gravitational well with ease, creating gossamer shells of rarefied gas that stretch for thousands of kilometers above the surface. These atmospheric halos are so thin that they would be considered perfect vacuum by earthly standards. Yet they create a gradual transition between the planet and the void around it. Particles in the outer reaches of these extended atmospheres can take years to complete a single orbit, drifting in lazy ellipses that eventually carry them away into interplanetary space. The result is a world that seems to breathe its atmosphere into the cosmos, exhaling molecules into the darkness like a gentle cosmic sigh. There are cosmic phenomena that repeat in cycles lasting millions of years, creating rhythms too slow for any living thing to perceive. Throughout the universe, certain processes unfold according to schedules that span geological epochs. The orbit of our solar system around the galactic center creates subtle changes in our cosmic environment that cycle over periods of roughly 200 million years, influencing everything from cosmic ray exposure to gravitational interactions with nearby stars. These ultra-long cycles operate like cosmic seasons, each phase lasting longer than complex life has existed on Earth. During some phases, our solar system passes through the galaxy's spiral arms, encountering higher densities of gas and dust. During others, we drift through the quieter regions between the arms, experiencing a more serene cosmic environment. These rhythms have been playing out since the galaxy formed, creating a temporal music too slow and vast for any conscious mind to follow. Some molecular clouds in space are held together by magnetic fields weaker than a refrigerator magnet. The vast stellar nurseries where new stars are born are often bound together not by gravity alone, but by magnetic fields so subtle they would barely affect a compass needle on Earth. These gossamer magnetic threads weave through the clouds like invisible cotton candy, providing just enough structure to prevent the gas from dispersing into space before stars can form. The magnetic fields in these clouds are constantly shifting and evolving, responding to turbulence within the gas and pressure from nearby stars. They create a delicate balance between expansion and collapse, allowing star formation to proceed at a measured pace over millions of years. Without these gentle magnetic constraints, the gas clouds would either disperse too quickly for stars to form or collapse too rapidly, creating conditions unsuitable for the gradual process of stellar birth. There are asteroid belts in other solar systems that sparkle like cosmic jewelry when viewed from afar, around many distant stars. Rings of rocky debris orbit in zones similar to our own asteroid belt. But some of these systems contain particles so reflective they create subtle glints of light that can be detected across interstellar distances. These sparkles come from highly polished surfaces created by eons of gentle collisions that have ground the asteroids into smooth, mirror-like fragments. When observed through powerful telescopes, these distant debris disks sometimes show brief flashes as individual particles catch and reflect their star's light at just the right angle. Each twinkle represents a tiny world tumbling through space, its polished surface acting like a cosmic mirror that sends a fleeting message across the light years. These stellar jewelry boxes remind us that beauty and order can emerge even from the chaotic process of planetary formation. Some gas giant moons experience auroras that would paint their entire skies in shifting colors. The magnetic environments around large planets create conditions where charged particles can interact with thin atmospheres in spectacular ways. On moons orbiting within these magnetic fields, the entire sky becomes a canvas for auroral displays that dwarf anything visible on Earth. These moon-wide light shows occur because the parent planet's magnetic field accelerates particles to such high energies that they can penetrate deep into even the thinnest atmospheres. The result is a world where the aurora isn't confined to polar regions, but instead paints the entire sky in sheets of moving color. Day and night blend together in a continuous display of luminous curtains that shift and flow according to the complex dynamics of the magnetic environment. There are cosmic dust grains that have been traveling through space since before the sun was born. Mixed within the interstellar medium are tiny solid particles that predate our entire solar system. Ancient specks of matter that formed in the atmospheres of long-dead stars and have been drifting through the galaxy ever since. These microscopic time capsules carry within their crystalline structures the chemical signatures of stellar processes that occurred billions of years ago. When our solar system formed from a collapsing cloud of gas and dust, Some of these ancient grains became incorporated into asteroids, comets, and even planets. Occasionally, these prehistoric particles reach Earth as components of meteorites, allowing scientists to hold in their hands material that is older than the sun itself. Each grain represents a journey through space and time that spans the history of the galaxy, a microscopic wanderer that has finally found its way to our world. Some binary star systems are so precisely balanced they could serve as cosmic scales. In certain double star systems, the two components have masses so nearly equal that they orbit around a point exactly halfway between them, creating a gravitational seesaw of perfect balance. These systems maintain their equilibrium with such precision that even tiny changes in mass or orbital velocity would be immediately detectable through alterations in their orbital timing. The gravitational dance between these perfectly matched stars creates conditions of exquisite stability, allowing planets to form in stable orbits despite the complex gravitational environment. Any worlds orbiting such systems would experience regular eclipses as each star passes in front of the other, creating a rhythm of light and shadow that could serve as a natural calendar. The mathematical perfection of these systems demonstrates gravity's ability to create order and balance on cosmic scales. There are regions in space where different types of matter exist in perfect equilibrium. Within certain stellar environments, the various forms of matter arrange themselves in layers of remarkable stability. In the atmospheres of some white dwarf stars, for example, different elements stratify according to their atomic weights, creating shells of pure hydrogen floating above layers of helium, which in turn float above heavier elements. This cosmic stratification occurs because the star's intense gravity sorts the elements with such precision that each type of atom finds its perfect equilibrium level. The boundaries between these layers are so sharp they could serve as natural laboratories for studying the behavior of pure elements under extreme conditions. These stellar onions demonstrate how gravity can create organization and structure even in environments of extraordinary density and temperature. Some planets have rings made of material so fine it behaves more like fog than solid matter. While we're familiar with the dramatic ring systems of Saturn and other gas giants, some worlds possess rings composed of particles so tiny they create structures that blur the line between solid matter and gaseous clouds. These gossamer rings consist of dust grains smaller than smoke particles, held in orbital formation by gravitational forces and electromagnetic effects. From space, these delicate ring systems would appear as translucent veils wrapped around their planets, visible only when backlit by their parent stars. The individual particles are so small and widely spaced that a spacecraft could pass through the rings without encountering a single grain. Yet collectively, they create structures spanning thousands of kilometers. These ethereal rings represent matter in its most delicate, organized form. Gravity's ability to create beauty from the finest cosmic dust. There are stellar explosions so distant, their light has been traveling toward us since complex life first appeared on Earth. Among the photons reaching our telescopes tonight are some that began their journey from exploding stars when the first complex cells were evolving in Earth's ancient oceans. These ancient messengers have been crossing the universe for hundreds of millions of years, carrying information about stellar deaths that occurred when our planet was a very different world. The light from these distant supernovae has been stretched and reddened by the expansion of space during its long journey, arriving as faint signals that require our most sensitive instruments to detect. When we observe these ancient explosions, we're seeing events that happened before flowers bloomed, before animals walked on land, before continents took their current shapes. Each photon represents a connection across both space and time to an era when life on Earth was just beginning to explore the possibilities of complexity. Some cosmic magnetic fields spiral through space in patterns that resemble the structure of DNA. The magnetic fields that thread through interstellar space often organize themselves into helical structures that twist and spiral across vast distances. These cosmic helixes are created by the rotation of stars and the motion of charged particles through space, resulting in magnetic field lines that corkscrew through the galaxy like enormous three-dimensional spirals. The resemblance to biological structures is purely coincidental, but it highlights the tendency of physical processes to create similar patterns at vastly different scales. These magnetic spirals can extend for hundreds of light years, slowly rotating as they move through space and influencing the paths of cosmic rays and the formation of new stars. They represent the universe's tendency to create order and pattern even in the apparent chaos of interstellar space. There are planets where the seasons last for centuries because of their unusual orbital characteristics. Some distant worlds follow such elongated paths around their stars that they experience seasonal variations spanning hundreds of years. During the brief periods when these planets swing close to their stars, they might enjoy temperate conditions suitable for liquid water. But for most of their orbital periods, they drift through the cold outer reaches of their solar systems, locked in winter-like conditions that could last for centuries. Any life that evolved on such worlds would need to adapt to these extreme seasonal variations, perhaps hibernating through the long winters or migrating between different regions of the planet as conditions change. The civilizations that might arise on such worlds would think about time and planning on scales that dwarf human experience, with generations dedicating their lives to preparing for seasonal changes that might not occur for centuries. Some gas clouds in space are so perfectly spherical they look like cosmic soap bubbles, created by the gentle stellar winds from dying stars. Some nebulae achieve such perfect symmetry that they appear as flawless spheres glowing against the darkness of space. These planetary nebulae form when a star's outer layers are expelled in all directions with such uniform velocity that they create expanding shells of gas that maintain their spherical shape for thousands of years. The physics that creates these perfect cosmic bubbles is surprisingly similar to the forces that shape soap bubbles on Earth, with pressure differences and surface tension effects creating stable spherical structures. As the gas shell expands and thins, it becomes increasingly transparent, eventually dissipating into the interstellar medium like a bubble popping in slow motion across cosmic timescales. These stellar soap bubbles represent some of the most geometrically perfect structures in the natural universe. There are cosmic ray particles that have more energy than a fastball thrown by a professional pitcher. Among the particles that rain down on Earth from space are some that carry truly extraordinary amounts of energy. These ultra-high-energy cosmic rays are individual atomic nuclei that have been accelerated to velocities so close to the speed of light that each particle carries more kinetic energy than a baseball traveling at 90 miles per hour. The sources of these incredibly energetic particles remain mysterious, as no known astrophysical process should be capable of accelerating individual atoms to such extreme velocities. When these particles collide with Earth's atmosphere, they create cascades of secondary particles that spread over areas the size of small cities, allowing ground-based detectors to study the properties of these cosmic projectiles. Each ultra-high-energy cosmic ray represents a puzzle about the most extreme environments in the universe. Some moons orbit their planets backwards, creating cosmic clockwork that runs in reverse. While most moons orbit in the same direction as their planet's rotation, a few rebellious satellites move in retrograde orbits, circling their worlds in the opposite direction. These backwards moons likely began as asteroids or comets that were captured by their planet's gravity and forced into orbital patterns that defy the normal rules of planetary formation. The gravitational dynamics of retrograde orbits create unique tidal effects and complex interactions with other moons in the system. From the surface of such a moon, the parent planet would appear to rotate backwards across the sky, creating sunrise and sunset patterns unlike anything experienced elsewhere in the solar system. These cosmic rebels remind us that even in the orderly realm of orbital mechanics, there's room for exceptions and surprises. There are stellar nurseries where magnetic fields sculpt the gas into structures resembling cosmic cathedrals. Within the vast molecular clouds where stars are born, magnetic fields interact with turbulent gas flows to create structures of breathtaking architectural beauty. These invisible forces carve out pillars, arches, and caverns within the gas clouds, shaping the stellar nurseries into forms that resemble the greatest works of human architecture. But on scales spanning multiple light years, the magnetic sculpting happens gradually over millions of years as stellar winds and radiation pressure work together with the magnetic field to hollow out vast chambers within the clouds. Young stars born within these cosmic cathedrals illuminate their surroundings with light that reveals the intricate details of the magnetic architecture, creating some of the most spectacular nebulae visible in our galaxy. These structures demonstrate the universe's ability to create beauty through the interplay of fundamental physical forces. Some asteroids have such weak gravity that a gentle jump could launch you into orbit around them. On the smallest asteroids and comets, gravity is so weak that human muscle power would be sufficient to achieve orbital velocity. A run and jump on one of these tiny worlds could send a person into a lazy orbit that might take hours or days to complete, transforming human locomotion into a form of personal spaceflight. The experience of moving around such objects would be unlike anything possible on larger worlds. Each step would become a small leap, each gesture a potential trajectory change. Walking would be replaced by a gentle form of three-dimensional swimming through the weak gravitational field. These cosmic pebbles represent environments where the normal rules of terrestrial movement break down, replaced by a physics of gentle floating and graceful arcs through space. There are galaxies so distant, their light shows us the universe when it was less than a tenth of its current age. At the very limits of our observational capabilities lie galaxies whose light has been traveling toward us for so long that it shows us cosmic history from when the universe was still in its infancy. These ancient stellar cities appear to us as they existed when the cosmos was less than 1 billion years old, providing windows into a time when galaxy formation was still in its earliest stages. The light from these primordial galaxies has been stretched to such long wavelengths by cosmic expansion that it can only be detected in the infrared portion of the spectrum. When we observe these distant beacons, we're seeing the universe during its first attempts at large-scale organization, when the first generation of massive structures was just beginning to condense from the cosmic dark ages. Each photon from these ancient galaxies carries information about conditions that existed before most of the stars we see in our local universe had even begun to form. Some neutron stars spin so fast they reshape space around them into spirals. Among the most exotic objects in the universe are neutron stars that rotate hundreds of times per second, their immense gravitational fields dragging the very fabric of spacetime along with their motion. This phenomenon, called frame dragging, creates invisible spirals in the geometry of space itself, like cosmic whirlpools that extend for thousands of kilometers around the spinning stellar remnant. The effect is so subtle that it can only be detected by observing how it influences the orbits of nearby objects or the polarization of light passing through the region. Yet despite its gentleness, this twisting of space-time represents one of the most profound demonstrations of how matter and energy can sculpt the universe's fundamental structure. These spinning neutron stars are like cosmic pottery wheels, shaping reality itself through their relentless rotation. There are dust lanes in galaxies that act like cosmic highways, guiding the formation of new stars. Threading through the spiral arms of many galaxies are dark ribbons of dust that appear to block starlight. But these seemingly empty regions actually serve as stellar superhighways. The dust lanes concentrate the raw materials needed for star formation and provide the cooler temperatures necessary for gas clouds to collapse under their own gravity. Young stars tend to form in chains along these dusty corridors, creating pearl-like strings of stellar nurseries that stretch across the galaxy's disk. The dust particles themselves are incredibly tiny, smaller than the wavelength of visible light, yet collectively they create structures spanning thousands of light years. These cosmic highways demonstrate how even the smallest particles can organize themselves into patterns that influence the largest scales of galactic evolution. Some exoplanets have clouds made of molten rock that rain liquid metal. In the scorching atmospheres of planets orbiting very close to their stars, temperatures reach levels where even rocks vaporize and metals exist as gases. These hellish worlds experience weather systems unlike anything in our solar system, with clouds of vaporized silicates condensing into droplets of liquid stone that fall as rain toward the planetary surface. On the hottest of these worlds, iron and other metals exist as vapor in the upper atmosphere, condensing into metallic rain at lower altitudes. The boundaries between different atmospheric layers are marked not by changes in humidity or temperature alone, but by the condensation points of various rocky and metallic compounds. These alien weather systems remind us that the familiar patterns of Earth's climate represent just one small corner of the vast possibilities that exist throughout the universe. There are binary systems where two white dwarf stars spiral toward each other so slowly they could take billions of years to merge. In the quiet suburbs of our galaxy, drift pairs of stellar remnants locked in gravitational embraces so gentle they barely seem to move at all. These double white dwarf systems lose energy through the emission of gravitational waves, causing their orbits to decay with such glacial slowness that the process spans cosmic epochs. The two stars circle each other in perfect silence, their orbital dance so gradual that entire civilizations could rise and fall between measurable changes in their separation. As they slowly spiral inward, they heat up imperceptibly, their surfaces gradually warming from the gentle tidal forces of their approaching companion. Eventually, after eons of patient convergence, they will merge in an event that may briefly outshine their entire galaxy. Some cosmic voids contain wandering galaxies that have been ejected from their original clusters. Drifting through the vast empty regions between galaxy clusters are stellar cities that have been cast out from their original neighborhoods by gravitational encounters. These exile galaxies travel alone through the cosmic wilderness, their billions of stars maintaining their collective structure despite being separated from the nearest galactic neighbors by hundreds of millions of light years. The journey of these wandering galaxies spans billions of years as they cross the empty voids at speeds of hundreds of kilometers per second. From any planet within such a galaxy, the night sky would be remarkably sparse, with only the galaxy's own stars visible against an almost perfectly black backdrop. These cosmic nomads represent the universe's ability to relocate entire stellar civilizations across distances so vast they challenge our comprehension of space itself. There are planetary rings so thin they're essentially two-dimensional structures floating in space. Some of the most delicate ring systems in our solar system exist as gossamer sheets of material so incredibly thin that they have almost no vertical structure at all. These ring systems are maintained in their flattened geometry by the gravitational influence of nearby moons, which act like cosmic shepherds to keep the particles confined to an almost perfectly flat plane. The individual particles in these ultra-thin rings follow orbits so precisely coordinated that the entire structure behaves more like a liquid sheet than a collection of solid objects. Waves and spiral patterns propagate through the ring material with fluid-like motion, creating dynamic structures that shift and evolve over time, scales ranging from hours to years. These two-dimensional worlds of orbiting particles represent matter organized in its most geometrically constrained form. Some stellar remnants cool so slowly they will remain warm longer than the current age of the universe. White dwarf stars begin their existence at temperatures of tens of thousands of degrees, but they cool with such extraordinary slowness that even the oldest white dwarfs in our galaxy are still glowing with residual heat from their formation billions of years ago. The cooling process is so gradual that these stellar embers will remain detectable for trillions of years into the future. The physics of white dwarf cooling is governed by the quantum properties of their degenerate matter, which conducts heat with such efficiency that the temperature drops follow precise mathematical curves that span cosmic timescales. Some of the white dwarfs we observe today will still be glowing faintly when the universe is 10 times its current age, serving as cosmic hearths that maintain their warmth through the deep future of space and time. There are molecular clouds where organic compounds form naturally in the cold darkness of space. In the frigid depths of interstellar clouds, where temperatures hover just a few degrees above absolute zero, complex chemistry unfolds with surprising richness. These stellar nurseries contain not just the hydrogen and helium left over from the Big Bang, but also a diverse array of organic molecules that form spontaneously in the harsh conditions of space. Amino acid precursors, alcohols, sugars, and other carbon-based compounds drift through these cosmic laboratories, created by reactions that occur over millions of years in the near-perfect vacuum between stars. The chemistry happens so slowly that individual reactions might take centuries to complete. Yet the vast timescales available in space allow even the most improbable molecular combinations to eventually occur. These interstellar chemical gardens suggest that the building blocks of life are among the most natural products of cosmic evolution. Some galaxies experience gravitational lensing so extreme they appear as perfect rings of light in the sky. When a massive galaxy cluster lies directly between Earth and a more distant galaxy, the cluster's gravity can bend light so dramatically that the background galaxy appears as a complete circle of luminous material surrounding the lensing cluster. These Einstein rings represent one of the most striking visual confirmations of general relativity's predictions about the behavior of light in curved spacetime. The perfect symmetry of these cosmic mirages requires an almost impossible alignment between the observer, the lensing cluster, and the background galaxy. Yet despite their rarity, dozens of these perfect gravitational rings have been discovered, each one serving as a natural telescope that magnifies and distorts the light from galaxies too distant to observe directly. These rings of light demonstrate the universe's ability to create its own optical instruments from the fundamental geometry of space-time itself. There are planets where the magnetic field is so weak that solar wind sculpts the atmosphere into comet-like tails. On worlds lacking strong magnetic fields, the charged particles streaming from their parent stars can strip away atmospheric gases and carry them off into space like invisible rivers. Over geological time, this process can create extended tails of escaping atmosphere that stretch for millions of kilometers behind the planet as it orbits its star. These atmospheric tails are completely invisible to the naked eye, but can be detected through their effects on radio waves and charged particles in the solar wind. The planets themselves gradually shrink as their atmospheres are eroded away, eventually becoming bare rocky worlds surrounded by thin shells of escaping gas. This gentle but relentless process represents one of the ways planetary atmospheres can evolve over cosmic timescales. Some cosmic dust particles are older than the solar system and carry the chemical signatures of ancient stellar explosions. Mixed within the material that formed our sun and planets were microscopic grains that had been wandering through interstellar space for billions of years before our solar system even existed. These pre-solar grains preserve within their crystalline structures the isotopic fingerprints of the stellar furnaces where they were created. When scientists analyze meteorites in terrestrial laboratories, they occasionally discover these ancient particles embedded within the younger solar system material. Each pre-solar grain tells a story about stellar nucleosynthesis that occurred in stars that lived and died before our sun was born. These microscopic time capsules allow us to study the chemical evolution of our galaxy by examining individual atoms that witnessed the universe when it was fundamentally different from today. There are regions in space where different physical constants might have slightly different values. In the vast emptiness between galaxy clusters, some theoretical physicists propose that the fundamental constants of nature might vary by tiny amounts across cosmic distances. These variations would be far too small to notice in everyday life, but they could have profound effects on the formation and evolution of cosmic structures over billions of years. The idea remains highly speculative, but if true, it would mean that the universe is not perfectly uniform even in its most basic properties. Different regions of space might have slightly different values for the speed of light, the strength of gravity, or the masses of fundamental particles. These cosmic variations would create a kind of meta-weather system operating on scales larger than galaxy clusters, where the laws of physics themselves might ebb and flow like invisible tides. Some asteroids have such unusual compositions, they may be fragments of destroyed planets. Among the rocky debris orbiting our sun are objects with such strange mixtures of elements that they cannot be explained by normal asteroid formation processes. These peculiar bodies may be the shattered remains of planets that were destroyed billions of years ago by catastrophic collisions or gravitational disruptions. The chemical signatures preserved in these asteroid fragments provide clues about planetary formation processes that occurred in the early solar system, when gravitational interactions were more chaotic and destructive than they are today. Some of these objects contain combinations of materials that could only have formed under the high-pressure conditions deep within planetary interiors, suggesting they are literally pieces of worlds that no longer exist. These cosmic fossils remind us that our orderly solar system emerged from a much more violent and dynamic past. There are stellar explosions so energetic, they briefly produce more light than the rest of the observable universe combined. The most extreme stellar explosions, called hypernova or superluminous supernova, can release more energy in a few seconds than our sun will produce over its entire 10 billion year lifetime. These extraordinary events occur when the most massive stars collapse into black holes, while simultaneously ejecting their outer layers at significant fractions of the speed of light. The light from these cosmic beacons can be detected across billions of light years, making them visible from distances so great that we observe them as they existed when the universe was less than half its current age. Each hypernova represents the death of a star so massive that its final moments can temporarily outshine all the other stars in the observable universe combined, creating a brief but brilliant lighthouse that announces the birth of a new black hole to the cosmos at large. Some moons have surfaces so dark they reflect less light than charcoal. In the outer reaches of our solar system orbit moons whose surfaces are among the darkest known objects in nature. These enigmatic bodies absorb more than 99% of the sunlight that strikes them, appearing as nearly perfect black spheres against the star-filled backdrop of space. The extreme darkness of these surfaces is thought to result from billions of years of bombardment by charged particles and cosmic rays, which gradually break down surface materials into complex organic compounds that absorb light with remarkable efficiency. These natural light traps demonstrate that even in the vacuum of space, surface chemistry can create materials with properties that seem almost engineered for perfect light absorption. Walking on such a world would be like exploring a landscape made of shadow itself. There are cosmic magnetic field reversals that happen so gradually they span millions of years. Just as Earth's magnetic field occasionally flips its polarity, the magnetic fields that thread through entire galaxies can reverse their orientation over cosmic timescales. These galactic magnetic reversals happen so slowly that they are imperceptible within human lifetimes. Yet they represent fundamental reorganizations of the forces that shape interstellar space. During these reversals, the magnetic field lines that guide cosmic rays and influence star formation gradually weaken, become chaotic, and then reorganize themselves in the opposite configuration. The process affects everything from the paths of charged particles to the compression of gas clouds, subtly altering the conditions for stellar birth across vast regions of the galaxy. These magnetic seasons operate on timescales so long that entire stellar generations are born and die during a single reversal cycle. Some comets originate from regions so distant that their orbital periods span millions of years. At the very edge of our solar system's gravitational influence lies a vast spherical cloud of icy bodies that occasionally send visitors toward the inner planets on journeys that dwarf all human timescales. These long-period comets follow such elongated orbits that they spend most of their existence in the cold darkness beyond the orbit of Neptune, returning to the sun's warmth only once every few million years. A comet beginning its inward journey from this distant realm today might not return again until long after our current geological epoch has ended and new mountain ranges have risen and fallen on Earth. These cosmic time travelers carry within their icy cores chemical information about the solar system's formation, preserved in pristine condition during their long exile in the outer darkness. Their rare appearances represent meetings between our contemporary world and messengers from an almost incomprehensibly distant past and future. There are binary pulsars that serve as the universe's most precise clocks. Among the most remarkable timepieces in the cosmos are pairs of neutron stars, where at least one member emits regular pulses of radiation as it spins. These binary pulsar systems maintain timing precision that rivals or exceeds the best atomic clocks built by human technology. with some pulsars maintaining their rhythm to within nanoseconds over periods of many years. The orbital dynamics of these systems are so precisely known that astronomers can predict when the pulses will arrive at Earth with extraordinary accuracy, making them invaluable tools for testing fundamental physics and detecting gravitational waves. These cosmic chronometers have been ticking away with mechanical precision since before complex life appeared on Earth, and they will continue their regular beats long after our Sun has evolved into a white dwarf star. Some planets have such eccentric orbits. They experience seasons more extreme than the difference between tropical and Arctic climates on Earth. Worlds following highly elliptical paths around their stars undergo temperature variations so dramatic that their climates completely transform multiple times during each orbital cycle. During close approaches to their stars, these planets might experience surface temperatures hot enough to melt lead, while at the farthest points in their orbits, they become colder than the polar regions of Mars. Any weather systems on such worlds would need to adapt to these extreme seasonal variations, perhaps involving the complete freezing and sublimation of entire atmospheric components as the planet's distance from its star changes. The geological processes on these worlds would also be shaped by the thermal cycling, creating landscapes that are alternately baked and frozen on regular schedules spanning years or decades. These thermally variable worlds represent some of the most dynamically challenging environments that planets can experience. There are stellar nurseries where the process of star formation creates natural particle accelerators. Within the chaotic environments where new stars are being born, magnetic fields and shock waves combine to create conditions that accelerate charged particles to tremendous energies. These natural cosmic ray accelerators operate on principles similar to human-built particle accelerators, but on scales spanning multiple light years and with magnetic fields millions of times stronger than anything achievable in terrestrial laboratories. The high-energy particles produced in these stellar nurseries contribute to the galaxy's population of cosmic rays, carrying information about star formation processes across interstellar distances. Some of these particles eventually reach Earth, where they can be detected by ground-based observatories as messengers from the most energetic environments in our local galactic neighborhood. These stellar particle accelerators demonstrate the universe's ability to create extreme physics laboratories from the raw materials of gas, dust, and magnetic fields. Some galaxies contain supermassive black holes that are completely dormant, neither feeding nor growing, while many galaxies host active black holes that consume surrounding matter and blast out jets of high-energy particles. Others contain supermassive black holes that have entered states of complete quiescence. These sleeping giants possess masses millions of times greater than our Sun, yet they exert no detectable influence on their surroundings beyond their gravitational effects. The dormancy of these black holes may result from a lack of nearby matter to consume, or from previous episodes of activity that cleared out their immediate environments so thoroughly that no fuel remains within their gravitational reach. These quiet monsters represent the universe's ability to create objects of almost unimaginable mass and density that can nonetheless remain virtually invisible for billions of years at a time. Patient leviathans waiting in the centers of their galaxies for the next cosmic meal to drift within their grasp. There are cosmic winds so gentle they would feel like the softest whisper against a feather. Flowing through the vast spaces between stars are currents of charged particles that move with such delicate grace they make a summer breeze seem violent by comparison. These interstellar winds are composed of atoms so widely spaced that billions of them could pass through your body without a single collision. Yet collectively, they create streams of matter that flow across the galaxy like invisible rivers. These stellar breezes carry the chemical signatures of their origins, transporting elements forged in ancient supernovae across distances that span multiple spiral arms. The particles within these winds have been traveling for millions of years, maintaining their gentle momentum through the near-perfect vacuum of space. When these cosmic zephyrs encounter magnetic fields or dense gas clouds, they create subtle pressure variations that help shape the architecture of the interstellar medium, sculpting space itself through the accumulated effect of countless gentle touches. Some planetary systems have gravitational harmonies so perfect they create celestial music that plays for billions of years. In certain solar systems, planets have arranged themselves in orbital relationships so mathematically precise that their gravitational interactions create standing wave patterns reminiscent of musical chords. These resonant chains of worlds maintain their harmonic relationships through subtle exchanges of orbital energy that keep their periods locked in simple ratios for geological ages. The gravitational music created by these systems operates on frequency scales far too low for human perception, with complete movements spanning thousands of years. Yet the mathematical beauty of these orbital symphonies rivals any composition created by conscious minds. Each planet contributes its own gravitational note to the cosmic orchestra, while asteroid belts and minor moons provide subtle harmonics that enrich the overall celestial composition. These systems represent the universe's capacity for creating art through the simple operation of physical laws. There are nebulae that glow with such pure spectral lines. They serve as cosmic laboratories for studying the fundamental properties of matter. Scattered throughout our galaxy are clouds of gas so rarefied and pristine that they emit light at wavelengths corresponding to individual atomic transitions with almost laboratory-like precision. These natural spectroscopy chambers allow astronomers to study the behavior of atoms under conditions impossible to replicate on Earth, where the gas densities are millions of times lower than the best vacuum achievable in terrestrial experiments. The light from these nebulae carries information encoded in the precise frequencies emitted by different elements, creating natural barcodes that reveal not only which atoms are present, but also their temperatures, densities, and motions. Some nebulae maintain their pristine conditions for millions of years, serving as stable reference sources for calibrating our understanding of atomic physics on cosmic scales. These glowing laboratories remind us that the universe provides experimental conditions far more extreme and controlled than any facility humans could ever construct. Some asteroid impacts on airless worlds create glass sculptures that could survive for billions of years. When rocky projectiles strike the surfaces of moons and planets lacking atmospheres, the tremendous heat and pressure of impact can melt and instantly cool surface materials into natural glass formations. These impact glasses preserve the moment of collision in their frozen structures, creating sculptures that capture the violence of cosmic bombardment in forms of startling beauty. The glass formations created by these impacts range from delicate beads scattered across crater floors to massive sheets of natural crystal that reflect starlight with mirror-like perfection. Without atmospheric weathering to erode them, these impact sculptures can persist unchanged for geological epochs, serving as permanent monuments to individual moments of cosmic collision. Each glass formation tells the story of a specific impact, encoding information about the speed, composition, and angle of the projectile that created it in the patterns frozen within the crystal structure. There are magnetospheres around some planets that create invisible sculptures spanning millions of cubic kilometers. The magnetic fields generated by rotating planets carve out vast three-dimensional territories in space, creating complex shapes that exist only in the realm of charged particles and electromagnetic forces. These magnetospheric sculptures are constantly shifting and evolving as they interact with stellar winds and cosmic radiation, forming dynamic artworks that span distances greater than the planets themselves. Within these magnetic domains, charged particles follow intricate spiral paths that trace out patterns of mathematical elegance. The boundaries of these invisible territories are marked by shock fronts and current sheets, where different populations of particles meet and interact, creating regions of enhanced auroral activity and radio emission. These magnetospheric masterpieces demonstrate the universe's ability to create structure and beauty in dimensions beyond the merely visible, using magnetic fields as both canvas and sculptor. Some cosmic dust clouds are so perfectly spherical they appear to have been crafted by conscious design. Created by the gentle stellar winds from aging red giant stars, certain dust shells achieve such remarkable geometric precision that they seem almost artificial in their perfection. These spherical dust clouds expand outward from their parent stars with such uniform velocity that they maintain their shape across thousands of years, creating growing bubbles of cosmic material that preserve the exact moment of their creation. The physics that governs the formation of these perfect spheres involves a delicate balance between radiation pressure, stellar wind dynamics, and the gravitational influence of the central star. Any asymmetry in these forces would distort the expanding shell, yet some stars manage to create conditions so precisely balanced that their dust clouds achieve geometrical perfection that would be difficult to improve upon even with conscious engineering. These cosmic spheres represent nature's ability to create mathematical ideal forms through the unconscious operation of physical processes. There are binary star systems where the components exchange material so gradually the process resembles a cosmic ballet performed in extreme slow motion. In certain stellar partnerships, one star has evolved to the point where its outer atmosphere gently overflows its gravitational boundary, creating streams of material that spiral gracefully toward its companion across millions of kilometers of space. This mass transfer occurs with such elegant precision that it can continue unchanged for millions of years. The material streams between these stellar dancers follow paths dictated by the complex interplay of gravity, rotation, and magnetic fields, creating luminous spirals that wind through the space between the stars like cosmic DNA helixes. Where the transferred material finally impacts the receiving star, it creates bright spots that pulse and flicker as the accretion rate varies, adding visual rhythm to the gravitational choreography. These systems represent stellar symbiosis at its most graceful, with each partner contributing to a performance that spans cosmic time. Some planets have day-night cycles so long that entire seasons pass during a single rotation. On worlds where the rotation period spans months or years rather than hours, the concept of daily weather becomes meaningless as entire climate systems have time to develop and evolve during what would constitute a single day. These slow-rotating worlds experience temperature variations so extreme that the day and night sides effectively become different planets sharing the same surface. The atmospheric dynamics on such worlds create wind systems that flow from the permanently heated day side toward the eternally cold night side, generating weather patterns that persist for the equivalent of terrestrial seasons. Any life that might evolve on these worlds would need to adapt to environments where sunrise and sunset are generational events, with entire ecosystems potentially migrating around the planet to follow the slowly moving terminator line between day and night. There are cosmic ray showers so energetic that a single particle collision in Earth's upper atmosphere creates millions of secondary particles that spread across areas the size of cities. When the most energetic cosmic ray particles strike our planet's atmosphere, they trigger cascade reactions that produce avalanches of secondary particles spreading over hundreds of square kilometers. These extensive air showers represent the atmospheric aftermath of single atomic nuclei that have been accelerated to energies approaching the theoretical maximum possible in our universe. The detection of these cosmic ray showers requires networks of particle detectors spread across vast areas. As the secondary particles arrive at ground level spread over such enormous regions that no single instrument could capture more than a tiny fraction of the total shower. Each ultra-high-energy cosmic ray event represents a mystery about the most extreme acceleration processes in the universe, encoded in the pattern of particles that rain down across entire landscapes from a single point of impact in the upper atmosphere. And now, as our gentle journey through the cosmos draws to a close, let your thoughts settle like stardust on quiet water. We've drifted together through the universe's most soothing mysteries, from cosmic winds softer than whispers to stellar dances that span billions of years. These are the gentle enigmas that remind us the cosmos is not just vast and violent, but also patient and beautiful, filled with phenomena that inspire wonder rather than fear. Whether you're already drifting towards sleep or still floating in that peaceful space between waking and dreams, carry these cosmic lullabies with you into the night. Sweet dreams, and thank you for exploring the universe's quietest secrets with me.